Welcome to the Round 4 simulation. In this simulation, we are going to look at the system design to achieve the 7 functional requirements. This slide summarizes the 4 rounds so far. In round 1, we looked at the impact of the unit cost equation on work, quality, and output. In round 2, we looked at Kaizen improvements and used MRP as a type of silver bullet to solving problems. In round 3, we introduced the 7 functional requirements and started to look at balancing work to takt time and also the Heijunka system to kick off pull. In round 4, we're implementing a more detailed and sophisticated approach to implementing the pull system in the form of a traditional 2-card Kanban system approach. We have 2 takes in which we change the run size from 8 units to 4 units, and we contrast the differences. This is a reminder of the 7 functional requirements of the Lego manufacturing system design. Keep in mind that each of these functional requirements have long-term impacts to sustainability of systems. And also I'd like to emphasize the key idea that once we define normal in the system design, that leads to FR5, which enables us to be able to identify abnormal conditions and to set up a process for resolving those real time as well as for the long term.
Hello everyone, so we are into round 4 of our simulations. What are changes that we have made from round 3 to round 4? That's what we are going to be discussing. That's the intro session of round 4, alright? So, Joe, what changes have we made in round 4 or we are thinking about making versus round 3?
Well, if you remember in round 3, it was all about balancing. So you were an assembler along with Sarah, and we did a time study, figured out that Sarah could produce, her cycle time was less than the takt time, and so we moved you to the supply side to hopefully overcome the material replenishment issue we were having here in assembly. So if you remember, what we learned was that I was only demanding red parts from Sarah, and she would run out of red material, and she would have green and blue available, but she couldn't produce that because she just replaces what's consumed, and I was only pulling red.
Right.
So that gets us to the idea of leveling. So now we can change the run size so that we can pull red, green, blue in some sequence so that we can reduce the demand on the whole system.
Right.
And along with that, we need to understand the amount of inventory to carry here in assembly. So in this first take, we're going to show worst case scenario where we run all the red, all the green, and all the blue.
With having the idea in mind to reduce the changeover time and all that.
Correct.
Yeah.
So we'll run all red, all green, all blue, and we figured out from our Kanban calculation we need 4 containers of each type to be able to meet customer demand.
Right.
And so another thing that's a little different this time is the customer asks us to ship in containers of 4. So to run all the red first, we're going to pull a container of 4 red, and then a container of 4 red, 4 green, 4 green, 4
Right.
blue, 4 blue.
Right.
That gives us 8 of each color.
Correct.
So, and then later on, we're going to reduce the run size by staggering these. So red, green, blue, red, green, blue. So take 2 will show that, and it will show that the inventory is different when we reduce run size. And we're able to change run size like that because of the new layout that we've come up with in assembly. That because Sarah has all the
ideas.
yes, because Sarah has all the material available to her, she's
Right.
able to produce any color when needed. And she'll explain that more here in a minute about her new station design.
Yeah.
In round 3, we calculated takt time to be 8 seconds per unit. The consequence of understanding takt time is that we saw Sarah as a delay to meeting takt time in assembly. So part of the issue was managing the container flow into and out of assembly. So Sarah came up with the idea of a flow rack where parts flow from the top to her work area, and then she can simply slide the empty containers underneath the flow rack to exit the assembly station. This is an example of balancing the work to takt time and looking at any waste that exists in the work in order to meet takt time.
So, hey Joe, can you please also explain to the viewers how does the two-card Kanban swap work, knowing the fact that it is so crucial right here in your role, as well as with respect to communication between assembly and or the supplier and as well?
Sure. So this is our Heijunka box.
Mhm.
You know, we've labeled our takt time as 8 seconds, and we have a pitch of 32 seconds because we have 4 in a container
Right.
times our 8 seconds, which gives us these 32-second pitches.
Intervals, yeah.
Yep. So at every 32 seconds, I will pull a card off of the Heijunka box.
WK.
Yep. So on the Heijunka box, we have a WLK, and each of these cards represents a container of 4 parts. So to make my order at the end of the day, I'm going to have, 4 red and 4 red, which gives me my 8 red, 8 green, and 8 blue. So at time 0, the timer will tell me, pull a WLK. And down here I have finished goods inventory, and I have a container of red, container of blue, and a container of green. And what I'm going to do is I'm going to take the WLK and I'm going to swap it with the POK, and the POK is here on top of the container. So I swap it and I move it to shipping. That is a good container of 4 parts ready to go to the customer.
All right.
And this tells me to then go back and make 4 red. So
Production of the
I will inspect and make a container of 4. And there's a chance during this I have, a defect, and there's this buffer between Sarah and I that, helps ensure I won't have to wait on her, and there'll be another part I can pull.
Correct.
And I place my POK back on the container, and I put it back in finished goods inventory. Now we're back to, where we were.
Right.
And the goal is that work is designed to be done before the timer goes off
At 32.
at 32 seconds, and now I'm going to produce a container of green. So,
Not produce, withdraw a container
Right.
of 4.
I'm going to do the swap.
Yeah.
So I take the POK off, I put the WK on, container of 4 green,
It's withdrawn.
move it to shipping,
Go for production.
production ordering Kanban. I make a container of 4 green. I don't have 4 green, but I have it over here. So container of 4 green.
Full inspected, good parts.
Yep, and that goes back into my finished goods inventory.
Until it's time for another pitch of 96, 64, and then it goes on like
And if I'm running to takt time, when the timer goes off, I will be ready to pull this WLK. I will swap it with the POK, move it to shipping, and I will go back and make a container of 4 blue.
Well,
And that will go back to here to replenish
well explained. I
finished
think,
goods inventory.
yeah, and the same goes on over there at the supplier end as well.
This figure is an abbreviated value stream map of the 2-card Kanban system for the simulation. Here we see the Heijunka box on the upper right corner of the diagram, which illustrates the leveling and pacing function. A withdrawal Kanban was removed at time 0 to pick up a container out of SWIP location number 3. The container in SWIP location number 3 had a POK in it, and so that's sent back to inspection to trigger production to replace SWIP location 3. The full container of parts with the withdrawal Kanban is then sent to shipping. Notice that only good quality products are delivered to SWIP location 3 after inspection.
So Ankar, after I use my container and I pass it under, what are you going to be doing next with it?
So when the timer starts, I will start after 15 seconds. I will come here and I will get empty containers from here. After getting the empty containers, so I will be doing the same thing. This is like a 2-card Kanban system I will be using, just like Joe is doing. I will put my empty containers here, and I will just simply swap my cards, and I will give the card. I will place my cards in this section, and I will ship it back to the assembler's end.
Alright. And then when it comes to me helping replenish the inventory for the supplier, I'll be picking up the POKs based on the first in, first out. So we got labels here 1, 2, 3, 4, 5, 6. So I'll be picking up the oldest card first and then like that. So that will be my 5-4 down here for replenishing the material.
Here we are illustrating a Heijunka box, and notice that each withdrawal Kanban card represents a container of 4 units. So by placing 2 Kanban cards in sequence of the same type, we now have a run size of 2 cards, container size of 4 equal 8 units. And the pitch of removal of the cards is based on the takt time. So since the withdrawal Kanban card has 4 units in it and our takt time is 8, the pitch of removal is every 32 seconds for these withdrawal Kanban cards. So this is the physical layout of our manufacturing system for take 1 of this round. Notice that the standard work in process, or SWIP, in assembly is 4 units, and our run size with the Heijunka box is 8 units.
Prepare. 3, 2, 1. Work.
All right, so here we are on take 1, round 4 conclusion. As with the tone of having people as our important asset, we are going to start with the internal customer satisfaction to find out if everything went well, and then we are going to make our way toward the external customer. So, starting with the assembly maybe, how did you find it this time?
I think everything went extremely well. This was the first time I used my flow rack, and so all the material was able to come right at me, and I had everything very clearly organized. And then I never ran out of material, and I was able to keep up with our SWIP.
Yep.
So, then I had my defects, and it just all went really well.
Awesome. How about the supplier end?
With the help of this Kanban cards, it was very helpful for me. There was no confusion.
You mean the WLK, POK swap?
Yes, yeah. So it was very smooth transition for me, and also I had one helping hand at this end, so
Yeah.
it was very smooth for
Yeah.
me too.
All right, so yeah, I found it very easy for me to help out the supplier as well with my new responsibility now because of the WLK, POK swap, and I could easily keep up with it. So, well, that was our internal customers. How about our external customer? Is the external customer eventually happy?
Yeah.
Did we make it this time?
I think we finally made the external customer happy. We have
Yay.
8 good of every color shipped in containers of 4 like the customer asked. And we actually are ready for the next day of production. So
Awesome.
we have finished good inventory replenished here. The decoupler between Sarah and I has 2 of each in it. And we just finished blue. So blue is in the truck ready to come back tomorrow morning, the next shift. But she is ready with red and green completely restocked. So we could restart right now, and I'm confident we could produce 8 of each again the next round.
Awesome. But I do have a question. Like if you notice lean, most of people would say lean means 0 or no inventory or as reduced inventory. So I see that one of the changes we made is we kept a little bit more inventory than we had in round 3. So does that mean we need to have more inventory in order to keep customer demand, or is there any other way to mitigate that?
Correct. The major change between this round and previous round, round 3, was that we did a calculation to understand the necessary material to have here on the flow rack so that Sarah would never be starved of parts.
Right.
And we figured out that that was 4 containers of each.
Mm-hmm.
So, said another way, to overcome the incoming defects from supply, the functionality test related defects here after assembly, and based on our run size of producing all the red, all the green, and all the blue, we have to carry that much inventory.
Okay, so that's as per our updated Kanban calculation, correct? All right. So my question again is like, how do we reduce the inventory with continuous improvement mindset and still be able to meet our external customers' demand? Because at the end of the day, this is our goal, right? So how do we achieve our goal while going with lower inventory? Any ideas, guys?
Well, in this simulation, we have defects and we have leveling that are run size that's affecting our amount of inventory. And
Correct.
the defects coming out of assembly and coming into assembly from the supplier, those are fixed constraints that we're not allowed to change as part of the
Yeah.
simulation. But run size is absolutely within our control. And when we started this round, we ran 2 reds and then 2 greens and 2 blues. And that means that there is a large demand for red parts,
Mm-hmm.
and then a large demand for green, and a large demand for blue. And when we saw in round 3,
Interesting.
in round 3 we saw that even when Sarah didn't have red parts, she had green and blue, but we weren't asking her to produce them, because I was not polling
Right,
anything but red, for example.
right.
So we can change that consumption and reduce that bullwhip effect throughout the whole system just by staggering how we produce.
Interesting, yeah.
So we still end up with 8, so container of 4, container of 4, of every color, but now we go red, green, blue, red, green, blue. And this chunk of time here is what affects that Kanban calculation to allow us to drop the SWIP to 3 if we would switch to this sort of layout where we go red, green, blue.
And interestingly enough, it's not just helping out on all this and assembly and inspection, shipping, but also with the supplier, because if we have to supply green after red for red, so we still have enough time to provide and supply the necessary material, and assembler won't run out of it. Interesting.
Yeah.
So do you want to give it a try, or I mean, first of all, is everyone agreed with this idea? Collective
Sounds good.
agreement?
Yeah.
Awesome.
So we'll go ahead with take 2 in round
The same
4,
round.
and we will run exactly this. We will run container red, green, and blue, and then repeat.
Yeah.
And
This time with 4, right? 4 parts versus
4
8.
parts in each container. So.
Awesome. All right, stay tuned.
This is take 2 of the simulation, where we have a run size of 4 units. We are changing over from red to green to blue, and this is facilitated by the workstation layout and the flow rack in assembly, where Sarah is able to change over with 0 time from going from one product type to another. This is the physical layout for take 2 of the simulation. Notice the Heijunka box has a run size of 4, and that we have decreased the SWIP in assembly to 3. Typically, when we reduce the run size, we're able to reduce the standard work in process inventory. So for this take, we'd like to see if we can actually meet customer requirements with less inventory as a result of decreasing run size.
Prepare. 3,
2,
2,
1.
1. Work.
Welcome back, everyone. So right now we got take 2 of round 4. Let's go and ask our inspector to see how did it all go. So is the customer, external customer, happy with the output of the round?
Yes, again, we were able to produce
Yay.
8 of each color and delivered on time, the right mix, and I am replenished in my finished goods inventory for the next shift, and I know Sarah has replenished the decoupler here between us, and for the most part, the inventory is, she's set to start production again. So I think what's in the shipping container is what we're missing over here. We had 1 defect, and so
Based on functionality. So that's awesome. How about the run size? What effect did you see based on the run size reduction?
So we did the Kanban calculation, and we were able to only have 3 here feeding Sarah this time, 3 containers of each, because we ran red, green, blue, ran green, blue. We were able to level the demand on the whole system this time.
So if you notice, we leveled the demand, we reduced run size, and we also reduced the unnecessary inventory as they go hand in hand with each other. I see it more like continuous improvement, the physical solution of the very first initial effort that we have, which is to continually improve throughout the process. Yeah, awesome.
So like that's what we did. Like in the round 1, the setup was completely different. Now you can see Kanban, and the flow rack, the inventories, and we changed so many things like a POK or Kanban, and
Yeah,
so it's
two
like
thumbs up.
it's helping us to get better at what we do. So
Right. Awesome. And see, the best part is we just, like, nothing was, what's going to happen round 4 was planned in before round 1. We, evolved, the system evolved in order to make sure that the needs of our external and internal customers are met on time, every time. Awesome. So I would like to go towards Sarah to discuss the second FRM line, which is provide a safe and healthy work environment. Do you think on the assembly end, how do you feel about that effort? Did we meet that?
Yeah, I think one of the solutions is an ergonomic workstation, which is kind of what we did with the flow rack. So everything was in front of me, I didn't have to be turning around, I had to be bending over, I mean, it was all just right, ready to come right in front of me on my workstation, and I was able to discard my containers really easily as well.
Yeah.
So,
And you have a very nice adjustable height table for in case you want to sit and do your work or stand and do your work. So,
Awesome. And I mean, the same ideas could, at the end of the day, could be replicated at industry and real, work setups as well. So then, of course, 2 big questions from customers are, produce a customer consume quantity every shift, and most important these days, nowadays, is the flexibility and the mix, the variety every shift. Like, let's say red, green, blue. So how do you feel about that, Joe?
well, the Heijunka box allows us to do both of those. It allows us
Interesting.
to produce the customer consumed quantity as well as the customer consumed mix. So if we look at the quantity, we've figured out our takt time, and we've used the container size to figure out our pitch. So our pitch being these 32, 64, 96, and so on. But what it tells us is that how often we have to produce a part to be successful.
Right.
So we know that after 32 seconds, for example, we should have produced 4 parts, a container of 4 parts.
Right.
And we know after 32 seconds that if we have not completed that container of 4 red, that we are behind. And by the end of the day, by the end of the shift, we are not going to know if we're going to be able to produce 8 of each and meet customer demand. So even at 96 seconds, I should have just produced 4 blue.
Right.
And if I produce 4 blue at 96, I know that I am still going to meet customer demand that day.
So like traditional management approach, you don't have to wait until the end of the day to know whether you are behind, you are
Correct.
going too fast, or production or what. You know it at any given time during the entire simulation. You would know whether you are on track or not, given the pitch of the Heijunka box.
And we've designed the system so that we will produce that. We know we're going to win.
Exactly.
And if you remember round 1, the goal was produce as fast as possible and hopefully produce at least what the customer wants. Maybe more, but produce at least what the customer wants. And we often couldn't do it. You would
Right.
think, if we worked as fast as possible, we should be able to do it.
Right.
Well,
Or produce one color but
Correct.
underproduce the other.
correct.
So you meant to say Heijunka box, the pitch gives us an indication or gives us a measure, like after 32 seconds there's a drum beat. But the solution actually is, especially with Sarah and then all of us, to balance the standard work of the entire system
To
to
take time.
meet that take time and to meet
Correct.
that, to achieve that pitch delivery. Awesome. And then same goes for the mix too, right?
Correct, so with the mix, we're back to the Heijunka box, but it's the cards now here and the sequence in which we place them that allows us to produce the customer consume mix that day.
Yeah.
So, for example, we could just run a whole shift of red. You know what I mean? We could have all red Kanban cards through here. But at the end of the day, we've only produced red. The customer's not gonna get the blue and green
Right.
that they wanted. So
Right.
sorry.
It's all right. It's all right. I guess.
So what we do is we stagger the product types
Uh-huh.
like this, so that 4 red here and 4 red here, and here's the end of the day. So we know when we're done producing this, we will have 8 red, 8 green, and 8 blue.
Right.
And it allows us to produce what the customer wants this shift.
See, from my experience, personal experience of working in several industries, it's so challenging all the time. The supervisors have to run after production planners, supervisors, asking them, okay, well, what are we producing today? And that's the same question that they are going to ask every single day. And even during the day, if between the shifts or between one product model is finished, now what do I produce next? See, it's so simple, so visual, at any given time, if the customer changes mindset about the order or something, you can easily swap it here without even communicating it down the line if they are properly trained, given the training perspective. So easy and visual,
And
so easy to follow.
you brought up a good point about the balancing and the pitch,
Right.
was that we designed the work
Right,
based on this. This was the
Right.
instrument to run to that drum beat, but we
Right.
had to design the system to be able to do that.
right,
Same with leveling. Because we leveled like this, we had to have almost zero changeover in assembly to be able to switch from red, green, blue, and
Yeah.
continue that sequence. And by giving Sarah all of this material, she can do whatever color she needs with
right,
virtually zero changeover time.
Right.
So the board's really not the solution, it's the whole system design behind it that
right,
has allowed us to run
right.
this sort of sequence.
Very good point, yes, indeed. Then the next FR&9 was, of course, do not advance a defect to the customer of your work. So, of course, we are all playing as downstream customers for each supplier, customer-supplier connections. So, you guys would want to maybe put some light on that as well. What
Yeah.
solution do we have for that?
I know Sarah receives yellow parts, and
Yep.
I think in round 2, we developed a Pokioke device,
Yep.
and you're now able to sort those out.
Yep.
So-
And,
So, quality system, but having quality control, which is part of your standard work, to remove the visual inspect and remove those yellow parts.
and then we do a final functionality test
Functionality test.
to make sure that what looks like a good part may not function like the customer wants, so we check those again. So
Yeah.
both of these,
Solutions,
Yeah.
the quality system with these two legs.
keep
of-
us from
Yeah.
advancing defects to the customer, yeah.
Awesome. Immediately identify, one of my most favorite ones, and I think almost about the entire industries and these lean gurus, usually they have issues with it. Immediately identify abnormal conditions and resolve them for the long term. So how do you think we mitigate that effect?
Well, I think this one's best to show a little example.
Yeah, it's
So if I pull a blue card,
uh-huh,
it tells me to swap, move a container to shipping, and then take the POK
right,
I have here, and come back here and produce a production-oriented compound, produce a container of 4. So I start doing that, I inspect, and I start building a container of 4.
right,
And then maybe I get a defect.
right,
Maybe I get 2 defects.
yep.
But I have to keep going. And because I've now had wasted time due to these
Mhm.
defects, I may only be on 3 of my 4 when my timer goes off.
and it's asking to make red now.
So I have to pull this, but I can't go ahead and do this. I have to finish my container I'm on. That's
Right.
what my standard work is. So I put that there, and I keep going on this.
Right.
And I mean, worst case scenario, it takes me forever, and another time goes by.
And the Kanban cards
And they
keep on
start
piling
piling
up.
up. And so by the time I'm done with this one, and I replenish it, I am back to here, and I have what's called a Kanban pileup. And this is the indicator that I am not producing the takt time.
So that means every time you have a card in a pileup, unnecessary, that means you can identify the disruption right away.
Correct. And this goes back to producing the customer consumed quantity, that if I don't pull at these pitches
You
and
will be
acquire
behind.
these cards, I won't know where I'm at. I can't just wait until I'm ready to pull the green, because then
Yeah.
I don't know if I'm
And
gonna meet the demand
I
that
think
day.
I've lived and felt it very well over there as well, the exact same idea being represented on the supplier end as well. That I gotta make sure I can keep on supplying as soon as I have the POKs on me, otherwise, yeah. So, I mean, this brings up a good point of how you identify disruptions, or put another way, abnormal conditions. How do we resolve them for long time, so,
Well, this is one of those cases that this tells me that I'm behind.
right,
And generically, we would look at our green sheet standard work, and that would tell us how to escalate this issue to somebody higher level for them to help us get back on track.
right.
And so Subaru, for example, they'll raise their hand when they have an abnormal condition. So that could be part of my standard work here, is that when I see my cards begin to pile up, I could raise my hand, and my team leader could come help me, maybe assist me in, you know what I mean? Both of us working to
Right.
get back on track, so.
So once again, green sheet standard work here is more like your standard action plan when an abnormal condition happens. What do I do now? You refer to your standard work, we have a standard way of doing it even at that time. And then there is different escalation plans, so 2 cards required for your supervisors, 3 cards if there is another escalation plan on top of it.
Exactly. Yep.
Alright, cool. Last but not the least, and these are all the FRs that we actually had agreed upon based on our external and internal customers' voice, right? Voice of the customer. So, achieve FR1 through FR4, that is, achieve all these FRs in spite of variation. Because, you know, flavor of the month, people do great things, but then, according to literature, 90% or more of the implementations fail within the first 3 years of their implementation. So, if I would ask you, how do we make sure that we can consistently achieve these FRs in spite of the variations, like let's say functionality test?
Yeah, so let's first look at what our variation is in the system. It's our functionality test here, and it's also the incoming
1 out of
defects.
6.
But it's
Right.
also the truck delivery that has to happen here.
Right.
Delays in truck delivery, or issues with the truck, whatever. But and if you look at the Kanban calculation, the
Right.
equation for it, we factor in for this variation.
Accountability.
So the inventory we carry here is a symptom of our variation, which tells us our PS to this is our SWIP.
Right.
We carry extra inventory on hand so that Sarah's not starving for material if there's an issue in the round trip. And if I pull a defect, there's always another one sitting here that I can pull from, so I'm not waiting on Sarah to move forward. And that's, so that happens mostly in this SWIP case, but it also works in this decoupler here.
Mhm. So to summarize it all these rounds and everything, I think for what I learned, if it is lean, if it is any of these buzzwords going around, I learned the system design perspective out of it. That the entire system has to work in a series of customer supplier connections, and you don't just necessarily come up with, if you come up with preconceived notions that okay, my aim is to reduce inventory, 0 inventory, like we let's say had in the round first. we could never have achieved what we achieved today, and we did it over and over again.
Correct.
So this is only possible when you have the system design perspective, which inventory is one of the parts, maybe.
And that was my point, that we couldn't just use a Heijunka box and it would work.
Right.
It was everything in the system worked to the takt time.
Right, and everything balanced with each other.
Correct.
Awesome. Well, I hope you guys also enjoyed it all as much as we did.
Yes.
Doing it and learning more and more every time we did these rounds. So, yep, thank you. Thanks for staying with us.
So first of all, I'd like to thank you for walking through this series of videos with us. As you can see, system design is a journey, and it requires us to first, as a team, agree on the functional requirements of the system design that we're implementing, instead of copying lean tools. In this case, we see why the lean tools meet the functional requirements of the system. And I think it's important to realize that these types of physical simulations you can use for your own work environments to illustrate and to work with others to focus on improving the work itself. And that can help to kick off your continuous improvement programs at your facilities. The second FR, providing a safe and healthy environment, we illustrated through the ergonomic workstation design and the flow rack design, designed by the people who do the work themselves. And that's a very important point to remember as engineers and technologists, that we listen to and hear the feedback from the workers on the floor, from the people who actually do that work. And then the next two FRs, as you know, are part of the JIT pillar of the Toyota production system, where we produce the customer consumed quantity every shift and the customer consumed mix. We see that the quantity was achieved by balancing work to takt time, and that producing the customer consumed mix is achieved by leveling the run size with the Heijunka box. Not advancing a defect to the customer of your work is the second best approach to quality. The best approach is to prevent the defect altogether. And in this case, we did have a defect prevention device where we saw the yellow Legos before they entered assembly. This could be like a test to ensure that the capacitor that we're doing assembly has the proper capacitance prior to insertion in a surface mount machine. So that would be an electronics example. And then the second case is to prevent poka-yoke, where we don't move product from assembly to shipping because we put in a detect device via the inspection. And most importantly, the system, because it operates to takt time, helps us to identify whether we have an abnormal condition. And remember, an abnormal condition is one in which we know we're not meeting takt time and we need to raise our hand and say there's an issue. Part of system design is that we can build that into our system design, the ability for people to say, I've got an issue. We also looked at the importance of how the pull system, if Kanban cards were to pile up in front of inspection or in front of assembly, that we would know that there's some type of delay in the system. And finally, the standard work in process inventory and the pull system is a means to dealing with the impact of variation that will inevitably exist within a manufacturing system as we go forward. So FR6 captures the idea that even though we do everything possible to reduce variation, we still want to design the system to be robust to handling variation. So I hope you've enjoyed this journey and can use this type of physical modeling in your work as you go forward.